Hi. So I decided to make a problem for my Algebra 1 course. This is the main course that I teach, and so it's an activity I'll be able to use with most of my classes. I decided to make an activity as an introduction to our exponent unit. So exponents is a unit that it's pretty short, and we do it about halfway through the year. And I'm always surprised by the number of students who struggle with the exponents and by the number who struggle with it in the long term. And so since we do it, the unit about halfway through the year, we work with exponents throughout the rest of the year. And just remembering the exponent rules long term, like a week later, a month later, the next semester, whatever it might be, I'm always a little surprised by how students either forget the rules or shortcuts, or even just forget how to write the exponents out and look at those. And so this is just, again, it's a unit that came to mind because I'm always a little bit surprised when I have some students who struggle with it. So this problem that I decided to use is actually something I've previously used as an extension activity, but I thought it would be kind of cool to change it into an introduction or exploratory activity at the beginning of the unit. And so reading Colin's article about how to effectively teach problem solving, it really got me thinking about the ways I can incorporate a generation phase before moving into a consolidation or instruction phase. And so I think this problem is something that has the potential to build off previous knowledge if students have or remember looking at exponents before, but it is still something that they will be able to solve without having any knowledge of exponents. And that's why I thought it might be a really good generation phase, something they could use just to explore, just to kind of apply the idea or ideas that they will be seeing within the exponents unit. And then, so the problem is this. After opening an ancient bottle you find on the beach, a genie appears. As payment for freedom, the genie offers you $50,000 right now, or a magic penny that will turn into 2 pennies at the end of the first day, 4 pennies at the end of the second day, 8 pennies at the end of the third day, and we will continue this pattern for 28 days. So this problem, a lot of students just right off the bat think it's the $50,000, or would say they would take the $50,000 just because they don't really realize how much money the pennies doubling will amount to at the end of the 28 days. And so for this problem, I would have students work in groups, and I would give it to them at the beginning of class, basically as a bell ringer, and I'd take probably about 10 to 15 minutes. Again, I want to keep it short, just as a little introduction, just to get their minds thinking, just to kind of show them a context for the use of an exponent. And with that, depending on how the students are doing or how long it's taking them to look at the question and go through the prompts, I would adjust the amount of time I give them. But again, I would hope it would take them right around the 10-minute mark to read through it to get an idea for their answers. So first off, I would give them the prompts A through E. So which payment will you choose and why, just so they can get their initial idea or their initial thoughts when they're thinking about it. Then B, how much money would you have on the 28th day? C, describe the process you use to find the amount of money you have at the end of the 28th day. So B and C are areas where they can incorporate their problem-solving skills. And so when I was writing the questions, I was specifically thinking about Polly's model. So they'll need to think about what the question's actually asking and think about how they can devise a plan to find that amount of money. And so as they're doing that, hopefully that they realize that the amount of money is doubling. And once they realize the amount of money is doubling, there are different ways they could approach it and that carry out the plan stage. And then at the end, for their looking back, they can kind of look back and double check and maybe try out a different method if they have a different idea to see if their answer makes sense. Or for letter E, this kind of ties into the looking back stage. Looking back, can you think of a shortcut that would allow you to calculate the amount of money at the end of the 28th day? And so that's how it incorporates kind of those different problem-solving steps, or how I envision students following those problem-solving steps with this problem. And then letter D, I skipped that one, is which payment will you choose and why? And so after students have thought about it a little bit and found that amount of money on the 28th day, just comparing their initial reaction to their final answer, if that changes at all. So again, this is a problem I plan to use with my Algebra 1 students at the beginning of an exponent unit. And with this, we could come back to it at different times in the unit if we wanted, or maybe try and expand on it so it can incorporate those other exponent rules as we're going throughout the unit. But overall, I feel like it'd just be a good problem at the beginning of the exponent unit for students to start thinking about exponents before really jumping into the material. Thanks for